Okay, we're getting near the end of fractions, thankfully. It's been a lot of hard work to get here, but we're moving into dividing fractions, which is actually way easier than adding or subtracting, so this is going to be a nice break for you. The concept is not really that easy, but then I'm going to model the concept for you, then I'm going to show you the procedure. The procedure is really simple. But again, we don't want you just to memorize something because you'll quickly forget it. We want you to try, well, at least to try to help you see what's going on when you divide by a fraction. So let's start with 2 divided by 1/2. So if you go way back to division, which is probably a while back for you now, when we divide something, 2 divided by 1/2, we're really asking how many groups of 1/2 can we get from 2? So let's model that. How many groups of 1/2 can we get from 2? Let's model 2 wholes, 1, 2, and let's cut those wholes into halves. So we have 1/2, 1 out of 2, 1 out of 2, 1 out of 2, 1 out of 2. So we have we have halves there. We've taken that 2, we've cut it into 1/2. Now how many 1/2 do we get out of 2? 1, 2, 3, 4 is the correct answer. So the answer to that question is 4. Now keep that in mind. I'm going to write it here because I'm going to model it for you in just a second procedurally with the formula. And I may have you do a couple of these models, really simple ones in this lesson. We'll also have you practice the procedure. Then we'll skip quickly to the procedure and you'll be able to do really big numbers quickly and easily with the division process. So let's do the same with this. We'll draw a line here so we know we've got 2 separate problems. So if I take 2 and I break it up into thirds, so let's take the same 2 wholes. Probably already have this figured out in your head. And I break it up into 1, 2, 3. 1, 2, 3. So how many thirds can I get out of 2 wholes? And the answer is 1, 2, 3, 4, 5, 6. So the answer to that then is 6. So you can see through modeling why this works or why that's the answer. And I'm going to show you procedurally or using a formula how to get this answer, because modeling, as always is the case, gets really messy fast because we don't want to draw pictures of fractional parts up to the 50ths. That would take way too much time. So here's the procedure, really simple. When you multiply a fraction by a whole number, keep in mind this, just like when we multiplied, that's 2 over 1. I want to change it to a fraction. Anytime I'm dealing with fractions, I want to compare fractions to fractions. So go ahead and change that to a fraction, and then I multiply by the reciprocal of this, or the opposite. I flip it, I turn it upside down, and multiply. So 1/2 becomes 2 over 1, and then I multiply the 2, and look what happens. 2 times 2 is 4. Remember, rules for multiplying is multiply top, multiply bottom. 1 times 1 is 1. We know 4 divided by 1 is 4. So procedurally, using a formula, that's how we get there. Now let's do 2 divided by 1/3. Same procedure again. I want to take the first, make it a fraction, 2 over 1. Multiply this flipped, or this turned upside down. The reciprocal of that, that's called a reciprocal when you flip a fraction. And there are other reasons you may use a reciprocal in the future. Now 2 times 3 is 6. 1 times 1 is 1. We're going to recognize that as 6. So 6 divided by 1 equals 6, and it's just that simple. So we'll give you several practice problems to work on. You should have it down.